All right, welcome to your TypeScript adventure. I am your host, Dylan C. Israel. We will get cracking on some TypeScript tutorials. So why learn TypeScript? That's why we're here, right? What is TypeScript? Well, TypeScript is a superset of JavaScript. It can do everything JavaScript can do, and then some. It has grown immensely in popularity in the last year or two. Another great aspect of TypeScript is it's maintained and updated by Microsoft and the open source community, as is the wonderful Visual Studio Code IDE. It compiles down to regular JavaScript as well, so you can actually set in your TSLint settings what version of JavaScript you want it to compile down to, and that way you can still write the latest code while still handling all those edge cases for the less good browsers and the bootleg browsers like Internet Explorer. TypeScript also tends to be less error prone and is more readable and maintainable. Now, this is a little bit of an opinion on that aspect, but I think it is an excellent thing to make because the readability adds to cleaner code because now we can assign types and it's easier to find. So what are some of the things we're going to be covering? Well, we're going to get you started, of course, in types and make sure that you can use this not only in the Scrimba course, but we also want to make sure that you have the tools you need so that by the end of the course, you can go and run a TypeScript project yourself. We're, of course, going to be talking about variable types, return types, classes, enums, interfaces, intersection types, access modifiers, and a lot more in this course. These are just some of the more core concepts in the course. So let's go ahead and jump right in. All right. So as we get started here, you'll see we have these three examples, and we're going to be dealing with TypeScript. Much like how CoffeeScript wasn't about coffee, TypeScript will actually be about types. What I mean by that is that we are going to try and apply static types when possible to our variables and other aspects of our JavaScript. Now, by default, when we have these types, it's not defined. It will actually have a type of any. Now, if you want to pause the video and go into the text editor mode, when you hover over it, you'll see that it actually will be assigning that any type. So let's go ahead and get started and start applying some types in TypeScript. As I mentioned, any type here is essentially JavaScript's old versioning of, okay, we can make this variable anything. We can initialize it to 35. We can initialize it to a Boolean like true, an empty object. It can be anything. Now, in a more in TypeScript, and typically you want to avoid any because that's why we're using TypeScript, or one of the reasons. And we can go ahead and say, hey, we want this to be a Boolean, so this is going to be true. And if that works, but let's say we wanted to assign it to something like 35. We'll immediately get this error, which in the editor, if you pause the video and check it out, it will tell you that, hey, this type is not assignable to 35 because TypeScript is saying that this is a Boolean and you need to treat it as such and not assign an invalid type. Yeah. So let's go ahead and change this back to a Boolean, and we'll just create some other examples here where we're going to assign type number. And we can assign our 35, and then we'll assign type string here. We'll just set it to something like hello world. Now, you don't always have to assign a single type. We can assign multiple types, and we'll be talking about that in an upcoming section.
Hey there, I'm Per, and on behalf of the entire Scrimba team, I want to say thank you for using our platform. Our goal is to help you improve your skills so that you, in turn, can improve your career. And in order to achieve that, we've created over 30 courses on various front-end development topics. Here, you can see some of them, and these are all free. Actually, 90% of our courses are free. So you can learn React for free, JavaScript for free, Vue for free, and a lot of other subjects as well. However, once in a while, we launch what we call a bootcamp. A bootcamp is a massively comprehensive, in-depth course that aims to take you to a higher level in the subject that it teaches. So we have a bootcamp on responsive web design, we have a React bootcamp, and soon we're launching a Vue.js bootcamp and a UI design bootcamp as well. Now you might ask, why enroll in a bootcamp when we have all of these free courses? Well, Enrolling in a bootcamp is if you want to reach a professional level in the subject that it teaches. Because these bootcamps, they are massive. They're over 10 to 15 hours of content recorded by top-notch professionals in the given field. Really world-class people that knows what it takes to take you to a professional level. And they've created tons of interactive challenges which focuses on the subjects and concepts that students really struggle to understand. So this is what separates Scrimba from other platforms. You really have to get your hands dirty with the code, and you're forced to actually learn what you need to learn. Now, the bootcamps are fully self-paced, so even though they take a lot of time, you can take them in your tempo. Once you purchase a bootcamp, you get access forever. And if you ever need help, you get exclusive access to a Slack channel where you can connect with other students, where you can ask questions, and we in Team Scrimba will be there. And also the teachers will pop in from time to time to help out. Now finally, I just want to say that this is your way of supporting Scrimba if you want to do that, because the bootcamps is how we actually survive as a company. Without them, we simply couldn't have continued giving out free courses or developing the technology. So if you want to help us keep the lights on, please buy a bootcamp. It's highly, highly appreciated. We're only 4 people, so we don't need millions of dollars to build this platform. However, we do need to pay our bills as well. So you can help us with that by clicking on one of these images, and then you're taken to the given bootcamp. Or with these two, you're taken to the waitlist page where you can add your email so that you'll be updated when the course launches, and you'll also be given the very best price. So go ahead and do that. We have a full 30-day money-back guarantee, so there's no risk in just trying one out. And I hope to see you in the chat room for any of these courses so that I personally as well can help you become a professional in the subject that you choose. Thank you.
All right, the first thing I want to say before we assign multiple types here to our basic types, and there's many more types than this, and we'll probably go over a bit in more detail about those, is that generally in TypeScript, the idea here is to get to a single type, but that's not always possible, right? And instead of having you do any here, and now you can assign this as a Boolean, you could assign this as a number, you could assign this as an object, a string, whatever it is, we want to eliminate any's when we can. And so that one way that we can do that is by using the optional pipe here, which will say, hey, this is going to be a Boolean or it's going to be a number, one of the two. And so you'll see now we can go ahead and set this equal to 35. And it's that simple. But again, I want to just sort of preface that ideally what we would like to do is make sure that we are eliminating it to a single type when at all possible. All right, so far we've been showcasing how to assign explicit types, meaning that we're actually going to assign the value here. And sometimes we have to, right? In our example 2 here, we don't really know what it's going to be, and that's fine. So we would say, hey, we want this to be of type number. So when we reassign it later on, down below, we could say example 2 is equal to 35. And that's fine. So this is called explicit typing when we're putting on here. But let's take our string here and say we wanted to assign the type that this value is. This is a string, and it knows so. And if we were to actually pause the video and go and hover over our example, you would see that the type would be of type string. Now, we can do this with functions as well. Let's, instead of assigning the value here, take away the number and go ahead and assign. We'll take our example array, array.example, and we'll just call the reduce method on it, and we'll take num1, we'll take num2, arrow function, and we'll just want to return num1 plus num2. And what's going to happen here is this is now going to have a type of number array in our array example here, and we'll jump a little bit more into arrays and their types down below, but you can see this is our explicit type of number array. But if we took this away because of what we're assigning it to, it would still have the type of number array, which would be the implicit type. It's the same thing. It's just one way we're essentially hard coding the value, and the other way we're not. Now, when dealing with something like this, you with the optional types and having more than one type, you're going to have to explicitly say that, or it's going to assume that it's just a single type. So at this point, you're probably trying to figure out, how do I check the value as to see, am I getting the right class? Am I getting the right type? Right? And you first might say, hey, if you might think, oh, well, let's create an instance of our bear model here, our bear class. We'll just call this bear equals new bear, and the only thing in there is claws, and this bear has an extra claw. And we want to say, hey, if type of bear is equal to bear. Now, this might be the idea that I'm coming from, but this is actually not going to work because type of is testing only the initial types of JavaScript. It doesn't know anything about a bear class. All it knows about strings, numbers, booleans, objects, those types of things. However, we can use instance of here, instance of bear, is equal to bear. No equals though. Here we go. Bear, instance of bear. My apologies there. And this will say, is our bear an instance of the bear class? If it is, go ahead and put that in there. So that's how you're going to check your types and your models as you're defining them when they have constructors. And it's a great way to go about that. Now, keep in mind that if you're inheriting from multiple classes, it will pass as well because it is an instance of that as well. So you may need to narrow it down to the lowest level of the model that you're checking for. So sometimes you have to tell TypeScript you know better than TypeScript knows. And you'll see here where we have this any type that we had to assign to this string. It doesn't know it's a string because we've told it's an any. So we have to cast it as a string if we want to use these string properties. Let's give an example. So let's say we want to get the length of this, and we want to say definitely not a string dot length. We're typically going to get an error here that is going to, if we have a more stricter TypeScript, because technically it could be length, and this isn't going to be an issue. Because it's any, it could be a string, but it's not going to be an issue. But depending on the strictness of your TSLint file, it may say you need to explicitly tell it that, say like, hey, I'm acknowledging that this is an any type, but I'm going to say that it's a string. So we have to cast this as a string, and we can do that by wrapping this like this. And there's two different ways to be casting values. One is we can do it as a string. That would work as well. So we're now saying definitely not a string is a string. That's one way of doing it. And then the other way is to, in front of it, use these alligator teeth here. I guess that's what people in my work call them. I think it's kind of a strange name, but I live in Florida, but what do you know? You can cast this to a string, and then you will absolve that error. You don't have to worry about that. Now, typically, probably the best solution, if it's avoidable, is you would actually go and let this have an implicit or explicit type. But if there's a reason you can't, you can always cast it in both those ways. All right, so let's talk about types with arrays. By default, when you are assigning an array, it's going to assign that any array type. It's explicitly going to look like something like this. Now, let's say we wanted to have just an array of strings. We could do something like hello world. That would work, and this would be a string array. It definitely wouldn't be a number array, right? That doesn't make any sense. There's no number array values, and we'd get this TypeScript error. So you do a string array. We could do a number array here. Go ahead and pass in, I don't know, 1 and 2, and then we could do a Boolean array as well. Pretty much any type of an array of objects. It doesn't just have to be primary, sort of primitive values. We could have complex objects, our models as well that we've defined. So we could do true, false as well. We can also assign multiple types to our arrays as we did with our normal variable declaration. So let's say right here in this one too, we wanted to also have a Boolean of true. We're going to get this error, and you might do something like this where you say, hey, we want this to it, but this is actually saying this is going to be a number, or a Boolean array. So what you have to do, just have to take some parentheses and wrap these values like so, and now we can accept number or Boolean values in our array. Last but not least, let's talk a little bit about nested array values. So we oftentimes are dealing with multi-dimensional arrays, and you can do that as well with your array types by having this double nested value here. Now you're seeing we're getting error because we haven't wrapped this as an array, but we can like so with just by putting another array value here. And now we have a two-dimensional array of Boolean values in here. So it is a excellent and very easy way to say, hey, we are going to have a double nested Boolean array. Tuples are a relatively new idea when it comes to JavaScript. What they are is an array where we are saying, hey, at this value, at this index spot, 0, 1, 2, 3, whatever it may be, but in starting from the lowest, going incrementing upwards, there's supposed to be certain types, string, and then a number, and then a Boolean, for instance. So let's go ahead and create a tuple. So we'll call this example tuple. We're going to assign a type here of, let's say we're going to have string. We'll put my name, and then we'll put number, which will be my age, number. And we're going to go ahead and set this to an array. And so this first value has to be a string. So we'll say, we'll do some shameless promo. Go to https://www.youtube.com/coding tutorials360. So shameless plug. And then here, we'll go ahead and do something like my age, which is a number. Now, this is a tuple, meaning that we are expecting a string here, and we are expecting here at index 1 a number. Now, this doesn't mean that you can't add on to a tuple, but it does mean that this array is now of type string or number. But in these very first spots, it needs to continue on. So what I mean by that is that we can actually assign a number here as our third value. It doesn't follow a pattern of string number, string number, string number. It doesn't follow that pattern, but we have to put in strings. So we would put hello, or if we tried to pass in a Boolean, this would fail because this array, this tuple, is actually of type string or number. So those are tuples, a concept that's a little bit new to JavaScript, but should be pretty much familiar for those of you who are more familiar with more object-oriented languages like Java or C#. All right, so enums are another great addition to TypeScript that you traditionally wouldn't see in JavaScript. Let's go ahead and define an enum. So we're going to export an enum in our age enum. What we're going to have in here is a enum that we're just going to call it age. And in here, we'll have my age. So we'll say Dylan. And we're set this equal to 30. And then we're going to have my mother's age, which if you ask her, she is a ripe age of 21. Somehow I've outlived her for 9 years. I don't know. Doesn't have to make sense, but we're rolling with it. Then we're going to go ahead and, of course, import that into our application here. We're going to import age from our age enum file. Excellent. Now, we can reference these enum values, which by default, if we were to cross this out, would go 0, then 1. This is a number enum. And in here, we'll go ahead and say, have two values. We'll say, and what we want to return are the two values together. Return age 1, comma, or plus age 2, right? And so in here, we'll take, hey, we want to have age 1 of type age. And then we're going to have age 2 of type age. And because this is a string enum, this will work. And we can go ahead and just return those values. And this is, I use enums all the time when I'm going to like pre-populate drop-down values that we're going to have. But there's also string enums that we can have as well, where we could go ahead and create a new file here. And we'll do name enum, name.enum.ts. Our name enum, we're going to do the same thing, export enum name, and in here we'll have Dylan, or mine, and that will be Dylan, and we'll do mom's We'll go make head and make that mother. And of course, I do this so many times, but we're going to set these values equal to each other, not as an object, because they're in enum. And now in our agenum, or in our index.ts, we can go ahead and import these files as well. Which will just import names from our previous files, which is going to be name.enum.ts, no.ts. And now if we wanted to, we'd have access to the name variables, where if we say names.mine, it's going to return Dylan. And if we say names.moms, it's going to return mother. And we can use those. Enums are a relatively new concept to JavaScript, but really they're sort of a unique way to store values. And of course, if we wanted to just store a reference to like mine and as numbers, they would start off at 0 and 1 here, and we wouldn't have to assign any values, but we wouldn't be storing a string value. And string enums are a relatively new item to TypeScript. They got added just a couple months back. All right, so objects have been an interesting item when it comes to JavaScript. It has a very unique history because of the way that types work in sort of the back end of JavaScript, in the background rather. So let's take our 3 examples here. Whenever you see a capital object, a capital string, a capital number, you want to pretty much avoid that. And that's dealing with sort of outdated ideas. And the reason for it is because we can do really wonky stuff. So let's give an example. An object here in the lowercase object, this would be an object. That makes sense, right? We could also assign undefined. We could assign null as well, because we talked about that earlier. We could assign an empty array. It'd be a little weird. And personally, I think it shouldn't work, but it's technically an object. But what number that an item that we can't assign is not a number. And you'll see here, this is not a number in TypeScript, is inferred to be of type a number, and probably rightfully so. However, definitely not an object. But however, this will work here, undefined, false, all that sort of stuff, but not a number will actually work for our object here, which is one of the reasons you don't want to be using this. It's probably pretty rare that you want your object to actually be of type, not a number, or of type number. And then you can, of course, instantiate an object here. Now, we'll go ahead and do something like this. Now, you may be thinking that you can go and take example 3 and say, look, I want to add some, first name property to it and set it equal to Dylan. You won't be able to do that because this type is not of type it is of type object, but what we're actually really saying is, hey, this type here is a empty object, and that's all it's ever going to be. So when you try and assign this first name property, it doesn't exist on our object. So in the next section, what we're going to be going over is how to create models and interfaces and classes so that we can predefine our data structure for some of these more complex objects, so that these types, if they do exist, we can assign those values, and we don't have to worry about these magic string issues that happen a lot in JavaScript. All right, so by now you're probably saying, hey, Dylan, this is really great. We've assigned types to variables. How can we use TypeScript with functions? I'm glad you asked. So let's take our function add here. We can go ahead and assign parameter types to our parameters, and we'll just write a basic function to add 2 numbers together. We'll just call this val1. What type is it going to be? It's going to be a number. And val2, what type is this going to be? We'll go ahead and make it a number as well. And when we return here, we're going to add a type of, or when we return, we're going to add val1 plus val2. Now, when we go ahead and call this function add, you'll see that we're getting this normal JavaScript error because it's expecting 2 arguments but got 0. And you'll see when we hover over, hey, we expected number 1 and number 2, but we didn't get a val1 of type number and val2 of type number. So let's go ahead and pass in 1 and 10. Like, cool, that's a valid input. That's great. And of course, if we pass in a string, we're going to get an issue here because a string is not assignable to a type of number. We can, of course, use our additional types so that we have created. We are importing our person class here. So let's go ahead and create a person. We'll say this, set this. Actually, we'll take it in. I forgot we're showing parameter types. Why are we creating this? But here we'll go ahead and create we'll just call this person of type person that we're importing here. And what we want to do here is just return return a string, says something along, we'll use some backticks here, say hello to my little friend, and then your friend's name with an exclamation point. In our case, it's going to be person dot first name. Now, if you were in a text editor, then IntelliSense here would show you all the options that you have for your items. And of course, if we were going to say hello, we could do something like new person, and then we'll just say first name to Dylan, right? This is our model, so we don't have to pass in all the values. We don't want to. And so we have the ability to set various types. And of course, we wanted to set arrays, other objects that we've defined, or optional values. We could do that as well. All right, so we've added some stuff onto our previous example here with a void example and a never example as well. So far we've shown how to add values to models and interfaces, how to add parameter types, how to add types to variables, but how about return types? That's another great thing that we can do here. So you'll see here we're actually returning a type of number, and when we hover over, you'll see the colon on the end that says number. We're actually going to return that type as well. So we're going to add the explicit type of number, and that way if we say, hey, we want this to be a string, it's going to break, right? Our return type here is incorrect, and it should break. That's one of the values of Typescript. So here we're going to say, hey, we have a return type of number. And if we want to do the same thing here, it's expecting a return type of string. We can go ahead and explicitly say this. Now, I personally like saying the explicit return types, but I know my coworkers feel differently. But I think that one of the values to explicitly saying the type here is it's going to infer the type value here. So if we didn't put number here, and let's say for some reason we wanted to wrap this as a string and do like toString or something to it, we want to do something like that, it would just change the return type here of add. It would change it to a string because that's what it's returning. So it gives us a little bit of a check there to say, hey, this is supposed to be a number, and if you change this to a string by accident, on purpose, whatever it is, you need to at least acknowledge that and change the return type. So that's why I like saying that. So not everything's going to have a return type, right? So in our example, void example here, we're not actually returning anything. We're just calling a function that does some stuff. And here we're going to have a return type of void, because it doesn't actually return anything. It just calls some stuff. So most of the time you're going to use void for when you're not returning items. Now, there are other things that another great example. So let's say we're throwing an error here. Error. There we go. So we're throwing an error. What is the return type going to be here? It's not necessarily void. It's actually going to be never. The reason for this is because it never is going to reach the end of the function. Now, void would work in some examples, but it's more specific to use the never type, because never is this ever doing anything. It's just throwing an error. So you can also add, we'll talk a bit about generics and assigning types to them in upcoming sections as well. But you do have the ability to add return types. It's one of the things that I encourage people to do, although unless you have your TSLint set up properly to force people to do it, it is an optional item, as is most of TypeScript. All right, earlier in our example here, we wanted to be able to assign a new property, but we keep getting this error that's warning us, hey, this does not exist on our object. One way that we can get around that is by explicitly creating a type here with the type keyword, and we'll create this type and we'll call it person. And we're going to set this equal to what we want to create. In our example here, we want a object that has a first name type, and then you'll see we are assigning the variable type here of string. And so instead of actually having this as type object, we're going to go ahead and assign this to type person. And you'll see here that when we're trying to actually assign it to an empty object, we're going to get an error here now as well. The reason for this is because it doesn't have the first name property in the object, right? So we can actually go ahead and create a first name property here, and we'll just set this to Dolan. So Dolan as the first name. And now you'll see we have access to these properties as well. Now, one thing I want to stress is types. Creating types like this has sort of been deprecated in TypeScript. As you start working with things like TypeScript linters, this is going to be, there are rules to say, hey, create an interface instead of a type this way, or a class and assign it that way. And we're going to show that in the next video. But I think it's also important to just know that if you do see something like this, that this is a way to create a local type that's only going to be used in this file, while if you create an interface or a class in a different file, we'll have access to it. And for the most part, you're probably going to want to phase out types for interfaces and classes, though. All right, so let's go ahead and create an interface here. You see that we've added a couple of different properties here. We've added a first name, we've added a middle name, and we've added a last name assignment here. And we have this person class that we're actually going to rename as well. And we're going to have to assign some values. So an interface is a great way and the preferred way in TypeScript based off of their standards to create a type. And we're going to talk a little bit about classes / models and how those are different in the next video. But what we're going to do is use a little bit of ES6 logic here. So we're going to export a interface. And typically in TypeScript, you will go ahead and use the convention I for interface followed by the interface name. Now, this is a TSLint setting. I personally don't like it, although I personally use classes instead of interfaces 9 out of 10 times. So I'm going to drop the I off here because I think it looks bad. And what we're going to do is we're going to create properties here for this, and we're going to essentially create this type called person. And it's going to have a first name, and that's going to be a string. It's going to have a last name, and that's going to be a string. And it's actually going to have a middle name, and we'll put that in the middle because that makes sense. And that's going to be a string. So now we've defined this interface, which essentially will be our type. So now we can go ahead and import in here using the curly braces. And this is just some ES6 stuff, right? So we're going to import person from that file, which is going to be person.interface.ts. And notice the naming convention. This is something you don't have to do. And of course, we don't need to, when we're importing into the same file type, we don't have to add that on there. But you'll see here that we are, the name of the file is very descriptive. Now, this isn't something unique to TypeScript, but I think this is a good practice to have, that if you're creating a service, you're creating a component, you're creating an interface, you're creating a model, that you name it in such a fashion that you can look at the file and know what it is. So now we're going to go ahead and assign this interface. Now you'll see here that we're going to get this error because we don't have a first name, and we don't have a middle name, and we don't have a last name. And so we have to actually go and assign these values here, but at least we know what type of values they're going to have. So we'll have Dolan's first, middle, and last name are all the same. So we'll have Dolan, and now we can reassign those values because we've created an interface. And one of the ways that, this is a little bit separate from TypeScript, but we've now made it the ability that we can reuse this interface by exporting it. And it's also the preferred way of TypeScript when you just want to create a type. Now, we're going to be talking about how we can sort of avoid having to reassign all these values, and also how a class or a model differs from interfaces in the next video. Now, the next thing we're going to talk about isn't necessarily unique to TypeScript, but is something that you'll be doing a lot more in TypeScript, because as you go about defining different types of data and models and interfaces, you may have a lot of imports. So you'll see here that we are importing 3 different interfaces for our index: a man, a bear, and a pig. And one way to sort of clean up this code, if they're all coming from the same file, is in our interfaces folder here, we can create a index.ts file. In here, what we're going to do is we're going to export everything from each one of these files. So we're going to export from bear.interface. We're going to export everything from man.interface. And then we're going to export everything from our pig.interface. Now that we've done that, what we can do in our index.ts, or our homepage here, is we can use that barrel and eliminate the additional calls and put this, just putting a comma here to say, hey, bear, man, and pig from our interfaces file. Go ahead and import that. And it looks like, did I not forget to save or something? I think it's having a trouble registering it here. But that's just a little import here. Probably if we refresh the page in a second, it'll be fine. But what we're going to do is we're going to import from, let's see if it wants us to do the index.html, index.ts, excuse me, index page. There it goes. It wanted the index.ts file. No? But we can create this barrel that will import all of these interfaces that we've defined in this folder. And we can do it on one line instead of three, and it cleans up quite a bit of code. Now, the only thing to keep in mind is occasionally, if you have circular dependencies, this will cause issues. And you shouldn't have circular dependencies anyhow, but when dealing with nested classes, you may have some issues here. But in this case, they're all not related, and so we can save some lines of code by using our barrel file. One of the criticisms of interfaces is that they can't really enforce anything if it's coming from like a server side. We're basically assigning a type, but we're not able to assign default values. We're not able to assign methods, but that's a little beyond the scope of that. That's more of an object-oriented approach here. What we're trying to do here with our class file is we want to be able to assign default values. We want to actually be able to assign maybe instantiate a person and then assign the values like this without having to pass in a bunch of empty strings. We can do that with classes, and we're going to go ahead and create a new file here. And we're just going to call this person.model.ts. And in here, in person model, we're going to export a class, and we're going to call this person like we did earlier. And it's going to look very similar to how we initially set up our class here. And we're going to have our first name. That's going to be a string. We're going to have let's go ahead and put a space here. We want it to look nice, right? We want to have our middle name. And that's going to be a string. We're going to have our last name. That's also going to be a string. Now, the main difference here is we're going to be able to throw methods and items like that, is we can go ahead and use an inheritance. Anyhow, we're going to have a constructor here, and our constructor is going to actually build our object for us. So in our constructor, we don't have to have anything, but let's say we want to have something, or we want to have something and we want to make it optional, and we'll go ahead and set the data type here of any. We don't know what may or may not be passed in, and we can ignore the stuff that we don't want, right? We can pass in a whole bunch of stuff. And if we don't want it in our constructor, we're just not going to use it. And so in here, we're going to go ahead and say, look, this dot first name is equal to data dot first name. This dot last name is equal to data dot last name. And then this dot middle, I think this was middle name actually, so we'll fix that. It's equal to data dot middle name. And another thing is we can actually map these differently. I didn't mean to showcase this, but if we wanted to, we can actually say, look, the data.middle name that comes in, we actually want to map that to middle. We want to change that. Now, I don't want to in this instance, but we could if we wanted to. Middle name. Now, if none of these come in, we can assign default value much like this, where we'll just go ahead and set the default value to Dylan. Or we'll set the default value to, Israel, or whatever it is that we're trying to accomplish. And as I mentioned in our person class, we can, of course, have methods and functions as well. But this is one way that we could go ahead and have a constructor here that we're passing values in. Now, if we go down here, let's go ahead and just import our person class from our models file from /person.model.ts. And everything works as we can assign this and we could pass this in. Now, if we were going to, we have a constructor, so of course we want to use our person mapping here. And it looks like we're a little bit long here, so let's go ahead and bring it down on level, and we can wrap this and create a new instantiation here of what each one of these are, and we can assign the values. But we now have the option of like, hey, we're going to assign maybe these values later, and we just want to pass in a new first name, or we don't want to pass in anything. We're just going to assign it down below. And this way, we actually are saying, look, assign these values to this, or in here, in our constructor, change the mapping of these because we don't want it to be the same as what's coming in. So models in that aspect are much more powerful. And 9 times out of 10, I'll use a model as my type when I am creating them. All right, so we have our 3 interfaces being imported from our barrel here. Now, let's go ahead and use all 3 and talk a little bit about intersection types. Intersection types are the ability to add multiple types to a single entity, a single class, as well as creating a new type based off that. So sometimes we have a man, and he is not a man, just a man. And sometimes my girlfriend will say, sometimes a man may be a pig also. But sometimes we will have a bear, and he will be just a bear. And sometimes we will have a pig, and he will be just a pig. But sometimes we will have a man, bear, pig, and we want them to be all of those types. So we could do a bear and a man and a pig. Now we've created the man, bear, pig, which has the properties of our interfaces. So in our interfaces, we're going to have clause. We're going to have first name, a string. And then we're going to have pig with a bacon of Boolean. And our man, bear, pig here has inherited all of these interface properties. So when we go and we say man, bear, pig, and we say, hey, what do we want to do? First name. And we want to set it equal to Dylan. We can do that. And we want to say man, bear, pig. And we say clause. And we want to set that equal to 3. We can do that. And if we want to say man, bear, pig, dot bacon, and we want to set that equal to false, we can do that. Now, we can also go and use these intersection types, which is really just a fancy word to say combined types. We can actually just store it in a type or another intersection, and that's what I sort of recommend you do. But if you wanted to create, say there's one instance in which you're never going to touch it except this one time, we can create the type man, bear, pig, and we could set it equal to this value that we created down below, store a reference to it, and then in man, bear, pig, we're just going to assign the man, bear, pig type. So that's intersection types, really just a way of assigning multiple types to a new type or a new interface. Now you could do this in an interface or a model as well, but this is how you would do it just in your local function. Generics are another great example of something that doesn't exist in JavaScript that, if you've never coded in C# or Java or one of those higher object-oriented languages, you would never have been exposed to. But generics give us a way when we don't really have a predefined data type to still be able to manipulate it a little bit and add some clarity to it. So we could definitely use any, as we've been doing before. That would be all right, but maybe we want to actually pass a type. We don't know what it is yet, or we want to manipulate a type that we can have later on after we pass it in. We can do that with generics. The way that we do that is we can first start off by assigning this T here. Officially let it know that it's going to be a generic. And then this T here will be the type that we are expected to return in here. Right now we haven't returned anything, but let's say we pass in a value here. And our argument is of that type as well, that generic type that we don't know what it is yet. This is as basic of a generic function as you can get. In our case, we're just going to return it directly. And then later on, we'll be able to pick up that type that we're passing in here, whether it be, let's just say example, and in here we're going to return 5. So now we're going to be able to pick up that this is a number that's getting passed in here. And you can kind of see as it's being passed through, we understand what that's going to look like as our output. Now, we can also make it a little bit more complicated where, let's say we're passing in a type we don't fully understand quite yet, and it's going to be an array of values here. Now, we can handle that like so, but T is not assignable. This is where it's breaking down. So let's just put a 5 or something in here. and we're going to give it an argument of t here, and say we want to instead, what do we want to return? We want to return an array of t. We can handle that as well, where this argument is going to return the same thing. We can also change this up where we don't have to have that, right? Where now we know what type it is, we'll have the type, but we're going to say, look, return arg index 0. And not only have we successfully made it a generic function, we've passed in that generic type to our argument. And then also here we have said that the type output will be of this same type. So it's a much more specific way of essentially assigning a bunch of any's along the way. And it's a better way of going about it. And it's really only used when you don't necessarily know how you're going, what data types you're passing in, or you're going to be passing in multiple data types. All right, access modifiers are new ideas in JavaScript, but have existed in other object-oriented languages for quite some time. So what an access modifier means is that there's several. There is public, meaning you can pretty much do anything you want to it in terms of the property of a object, such as our bear here. There's private, which means that once you sort of set it, you can use it locally in sort of your code, but you're anyone outside of your code. So like, let's say you wanted to have a button that would change the value of a private variable, you're not going to be able to do that. There's read only, which means that, hey, once we set this value, it'll never get reset. And there's protected, which means that, let's say we're extending a parent class to a child class. That's the only instance of what we can do it, but we ourselves cannot call it directly. So that's a lot of information, but let's give a couple of examples here. So we're going to create a bear here, and we'll just call this bear equals new bear. Now, if we go into our bear class, you'll see here that we take in clause, a name, a tail, and we're setting those values. And this extends our animal class, meaning that it's inheriting this type string. Now, right now, if we were to create an animal, it wouldn't be an issue. We'd say, hey, animal equals new animal. And in here, I believe we're going to pass in a type. So we're going to pass in a type, and this is just going to be bear. Oh, and let's go ahead and make that animal. And of course, you want to make sure that you import your animal class from animal.model. Here we go. So now that we have that, that works just fine. But we don't actually ever want a user to make an animal class, but we still need bear to have access to it. What we can do here is we can make type of protected, and we can make constructor protected. There we go. And we can make this constructor protected as well. By default, why am I having such trouble spelling protected? By default, your types are public. So you don't have to actually instantiate that. It's going to assume that you want them public unless you don't. But now when we jump back to our index.ts, we're going to have an issue here instantiating a new animal because our constructor is protected. Now, you can see here, cannot read type of undefined. Our IDE is not giving us issue, but if we try to do this, we're going to get several issues. Now, one thing with the bear is we all have public properties in here by default. So clause, cool. Let's change that to public just so that we can see it. We can say, hey, that's fine. There's no issue here. And if we go down below and we say, look, bear.clause is equal to 3. Cool, you got 3 clause. Very nice, bear. Now we can also jump into our bear model here, and we'll make our name read only. Now this will essentially allow us to only, once we set it, never to touch it again. So let's jump into our index.ts, and we're going to pass in a name property here, and we'll call it Omega Bear, I guess. I don't know. But now if we wanted to say, look, bear dot name, and we wanted to reset this to something else, we're going to get an issue here because this is a read-only property, meaning it's a constant, essentially. We cannot reset the value of this. And then there's private. Private can be used for quite a few things. More often I use private, public and read-only, and protected, but private is another great access modifier where if we throw private on our tail here, we can go ahead and say, let's say by default, our tail was in fact true. We had a tail, and then the bear had an unfortunate incident where now its tail is false. We're not going to be able to reset that either. However, private serves a better, in my opinion, a better instance where, this is a private and only accessible through the bear class, meaning that it only exists in here once we set it. It's a private variable to this. It's somewhat closely related to read-only in that aspect. But here, what we can do in our index.ts, let's give a function example of how this might work. So we're going to jump into our bear model class here, and we're going to create a public function called add. And all we want add to do is we'll just add num1 and num2. And in here, let's return that, right? So num1 plus num2. Excellent. Now, what we might do for a private function is, say we wanted to have some additional logic that we didn't want to showcase to the user that was just sort of there to handle additional logic. Maybe it actually added the two numbers. And in here, we'll pass in a num1 and num2. And here, we wanted to sort of abstract our logic. We're actually going to do it right here, num1 plus num2, and hide that from the user. Maybe here we just do const result equals to num1 plus num2, and we would return result. In our actual index.ts file, in our bear class, we could go ahead and see bear.add, and we could call that, and we could see what that function is, right? Because if we don't instantiate, it's just going to return what's nested in the function. If we instantiate, it's going to do it there. But what's not going to happen, and of course we pass some numbers, what's not going to happen is we're not going to see the actual logic that's getting taken place in our private variables. So that's why I say that you're more often going to use private with your functions as you're defining your classes to hide that logic. Most of the time, that's sort of how you want to approach object-oriented programming, is you want to hide that logic behind private functions, excuse me. All right, so as I mentioned, I wanted to make sure that by the end of this tutorial, you can get up and going with your TypeScript and start developing on your local environment. And it's real easy to do that in TypeScript. All you have to do is first, you have to make sure that you have Node installed. You can go to nodejs.org/en for English. After that, once you have that installed, it comes standard with npm, and I usually use git bash to install, but in a terminal of your choice, install globally with npm install-g TypeScript, and after that, you're pretty much ready to go. You'll be able to create TypeScript files just by using a .ts file extension, and if you want to compile it down into a JavaScript file to see the output, you can by just saying tsc and then the file name. In our case, you'll see here that so tsc is the TypeScript command. Our file name, and the example is index.ts. One additional thing I wanted to talk about was that you can check your your JavaScript by going at the top of your file and putting a comment with a space and then at ts-check after you've installed TypeScript. This will show you how your JavaScript might have type errors in it, where maybe you're trying to map a string that normally you would only discover after it compiles and the user clicks on it. We can avoid all that and just check our JavaScript here to see where we might be able to make some fixes. So another great addition to TypeScript. If you're not ready quite yet, make the dive, but you want to play around and see, hey, is this actually going to benefit me? You can do it with just this at ts-check. One of the topics that you've heard me mention several times in this is the TSLint. So I want to talk real briefly about what TSLint is. It's essentially a way to write production level code and developer level code. It instills practices and clean code, good conventions that go along with TypeScript and JavaScript in general. And by default, it comes with a lot of normal setup. So sort of the TypeScript specification, according to the developers of it and the community. You can also, of course, configure your TSLint file. And so this link right here it's going to link back to my YouTube channel, specifically at the time where I run through the TypeScript TSLint setup. It'll take you about 5 minutes to get it up and going. I walk you through from start to finish of it, and then you can write the best TypeScript possible, the cleanest and most impressive code. Because that's one thing I wanted this course to do, so that you can get started today, right? This is an excellent technology and an excellent direction for JavaScript. I want you to get the most out of this. So as always, thanks for watching the course, and don't forget to check out the other Scrimba courses that we have covering algorithms, JavaScript, modern JavaScript, covering ES6, ES7, and ES8. There's lots of great courses on Scrimba. Don't forget to check them all out. Thanks, guys, for watching, and congratulations on spending the time and the energy to complete a course. Very few people get to the finish line, and it is a fantastic accomplishment that you're continuing to grow and learn as developers, and I hope to see you in the next one.